Can stats help us predict who's going to win the gold medal in curling at the Winter Olympics?
Keep watching to find out. Welcome to the Corridor of Uncertainty, the podcast at the intersection of maths and sport. My name's Jess.
And I'm Rich.
And we're both mathematicians at the University of York who love talking about sport. So we thought we'd make a podcast so we could talk about it even more. So, what are we talking about today, Rich?
So today is just about the start of the Winter Olympics. And at the Winter Olympics, there's one sport I love more than the others by a long way.
Because it's the best sport.
Yes.
Not just at the Winter Olympics, just the best sport, yes.
And that is curling. So you and I both love curling.
Absolutely love curling.
It is a fantastic sport to watch. It's got drama. It's got kind of tension, unbelievable tension. You know, the skill of the athletes is incredible. Skill of the curlers is incredible. But it's also got that strategy that really is, people refer to it as chess on ice because it's so strategic. So it's really kind of got a little bit of everything. And that's what we love about sport.
Absolutely.
So I thought I'd just introduce curling a little bit for those who haven't been blessed with watching any curling
And
yet.
look at you, you're about to uncover a gem.
Right, so in curling you have, in the most popular form of curling, you have two teams of four who take it in turns to slide a stone down an ice sheet to try to get it as close as possible to a target at the other end.
So it's a bit like bowls.
Yep.
In that we're throwing things down. Two teams of four, you say?
Yep.
And they get two.
Yeah, so each person has two stones and they take it in turns. So you have the first person from each team goes once, then they go again, and the second team person, and so on. And these people are called the first, second, third, and fourth. So that, at the end, in theory, well, everybody's thrown 8 stones in some fashion. Mm-hmm. The way that it's scoring was decided, I'll go into a little bit. But kind of one of the things that makes curling unique is it's on ice. That ice means that you can affect the stone as it's sliding down the ice. And that's what the typical image of curling is. One person watching a stone very carefully sliding down the ice. As you see in this picture, 2 people with brooms hovering over it. Those brooms can basically, with friction, melt a bit of ice, and they can help to, control the spin, control the speed of the stone, which can help shape it as it's going down the ice. Each of these, and then there's normally the fourth teammate is down the other end also shouting instructions to the 2 people with the brooms. There's obviously a lot more to it than that, but...
Yeah, so it's like, I was going to say it's like bowls, but in bowls, there's, as I understand it, there's like a jack or something, and it's I think it's scored in a similar way, isn't it? So you're kind of, whoever's closest gets a point and so on. Again, I'm sure you'll talk about this in a moment. But it's different because it's a fixed thing. It's not like a jack. You've got the centre, as you can see there, you've got the centre of the house. Yeah. Like, it's a bit more like archery, but like you say, not like archery because the scoring depends on where all the stones are.
It's kind of like archery if you had 2 people running alongside the arrow blowing on it as well to try and change the flight.
That would be excellent. That's superhero sports, yeah. Yeah,
so for the scoring on curling, I've got this example shot from some of World Curling's results.
Oh, excellent.
This is at some point in an end, so each team, there's normally 10 ends in a game. And in this case, for this snapshot, the yellow team is going to take 1 point because they have 1 stone closer to the centre than any of their opponent's stone. And that scoring kind of stops when you get to the opponent's stone. Yeah. So they don't have 2 because of the yellow on the top, or the yellow on the top is outside anyway, so it wouldn't count.
Right, so you've got to be inside those rings. Yep. Whoever's closest scores the point.
Yeah.
And then you keep going outwards. If you're the same colour, the same team is racking up points, but as soon as we hit a different colour, or we're out of those rings, no score. Yeah. And you can have nobody. If there's nothing in at the end, no one would score.
Yeah, so because it's that closest to the middle, this means that the final stone being thrown, because they're taking it in turns, is very, very important, because that final stone, if you can get it to land in the middle, you're automatically going to win, or if you can get it to land as closer to the middle than any of the other stones, you're going to score a point then. You're definitely going to score the point.
Yeah.
So that final stone is a big advantage.
Yep.
As you know, that stone is referred to as the hammer.
Having the hammer, yeah.
Keeping the hammer. So if you score using the hammer, you give it up for the next go, though. So that dynamic of keeping, and if you don't score, if there's no score on the end, what's called a blanked end, then you keep the hammer for the next go. So a lot of the tactics is about keeping that hammer for the more crucial go. So either taking lots of points rather than just taking 1 point, or keeping it for the last end so that you can make sure that you can get an extra point at that last end.
Anyway, right. Hopefully we've got
hopefully that's put in
our passion and the subtleties of this immense sport.
Yeah. It's like, as I say, it's chess on ice, except for the fact that because it's like chess on ice if putting the pieces on the board was actually also really hard. So like the chessboard was moving. Yes, it's like chess on ice, except, with darts, you're having to throw the pieces onto the board because it's also got that level of skill of making it very difficult to execute the strategy you want as well. And we'll touch on that a bit later.
Well, I think it's the only sport where you can impact what happens to it when it's left your hand. But it's great because it's kind of fast, but not that fast. So it's like, it's so gripping, like we say. I'm sure everybody has seen this before because Britain traditionally do quite well in it.
Yeah.
But if not, what a treat you've got. Watch it, and hopefully all the stuff that we've just said makes sense.
Yeah. So hopefully Britain's curlers will do well in this Winter Olympics. I wanted to look into the stats of it a little bit.
Obviously.
And for that, I actually looked at the World Championships.
Yeah.
Because the data was a little more easy to get for the World Championships. So, and in the World Championships, the nations compete not as Great Britain, but as Scotland. Yeah. Well, I was going to say Scotland, England, Wales, and Northern Ireland, but actually it's only Scotland.
Yeah.
It's only Scotland that compete in terms of GB. The GB team is always made up of the Scottish team, essentially. So for this curling analysis, I took 4 competitions, the 24-25 World Championships in the men's and the women's, both the 4-person events.
They have World Championships every year?
Yep.
Excellent.
Yep. So there are
you can always watch curling.
So this is all from Curl It, which is Curl IT.
Yeah.
The website is called Curl It. It's a fantastic resource for this. There are, in total in this data set, 336 games, which is 84 games per championships. So there are 13 teams in each championship, and they play a round robin first, and then they play knockout games afterwards. So round robin to decide positions in a table, and then they go through to knockout championships, depending on the number of teams. Will depend on how many knockout games there are. Normally there's 3.
Yeah, similar in the Olympics.
Quarter-final, semi-final, and a final as well, or a bronze medal playoff and so on. So look, that's the sport in basics. If we want to have a quick look at the results of what shows up, this is the teams. The countries here are the 13 teams from each of the years that are competing in it. The count is how many games they won in that competition, so that's across the round robin. I think I eliminated the knockout stages in this graph because not everybody plays in the knockouts, so it wouldn't be fair to see.
No, we didn't be inflating anyone who to them yet.
But you can see around the bar on the outside as well. It shows the if the team's medalled or not, what medal they got. I've also included 4th place because that's still doing very well. So they lost the bronze medal playoff game essentially. You can see the powerhouses here. So Canada dominate in both the men's and women's. They do very, very well in both the men's and women's games. In the women's games, there's also kind of but generally Japan, Korea do quite well. China do quite well. The Swiss do very well in both men's and women's. In recent years, the Scottish men have done very well. Scottish men won in the last World Championships, but the Scottish women have not done quite as well in recent years. Eve Muirhead has retired 4 Olympic Games. She's now off to a 5th as the chief of the...
I know. Do you know what's depressing? She's younger than me. It's depressing when someone younger than you retires from sport.
She was skip, so she was the captain of the team, making all of the decisions at 20 years old, which is incredible to go to your first Olympics as the captain as well. So, she's a bit of a curling prodigy.
Yeah.
Well, I mean, she won a bronze and a gold at the Olympics, so no silver. She's not completed the Olympics.
Not like the Brownlee.
Yeah. But doing two medals at the Olympics is pretty good. Yeah, so those are the main teams. It's mainly Switzerland, Canada, and then kind of these other teams, depending on what, on different years, can do very well. But yeah, Canada are the powerhouses. Mm-hmm. Sweden in the men, we should shout out as well for Nicholas Edin behind us as well. Incredible captain.
Right.
Yeah.
Yep.
Yeah. So this scoreline, this is just to show a typical scoreline. This is actually the final from the gold medal game from the last World Championships in the men's, Scotland versus Switzerland. You can see we've got our 10 ends. Switzerland started that first end with, I think it's called first end, last stone, or something like that. They refer to it as, but last stone, first end. That's what Switzerland started with. You can see it's quite a low scoring affair. That means it's going to be very, very tactical. Scotland, though, taking 1 point on the last end to take that gold medal. Wow. So that's kind of, you can see, as we're talking about the blanked ends, so they blanked the 9th end. They forced at the Switzerland at the 8th end to take those points, to take that single point, blanked the 9th, and then carried it in the hammer into the last one. I've got here the winning actual shot from Bruce Mouat, the Scotland captain. Yeah. You can see all he has to do with that last stone is make sure he gets it closer to the middle than that red stone. And he did. Perfect. As they call it, a draw when it's a gentle shot to the middle. We won't go too much into the shots because there's lots of different choices of shots. But that last stone, perfect draw, almost to the middle of the house to win the gold medal. A great shot.
Yeah. We love Bruce. We love Brucey. What an icon. There's a good piece on the BBC website that he's written a letter to his younger self, which is absolutely brilliant. So, yeah, we love Brucey. Yeah,
we'll link that in the show notes. So one of the things that I find really interesting about curling is...
Just one of the things.
One of the many things is this number at the bottom, actually, this percentage. So this number is the accuracy percentage. And it's actually a subjective measure, which we're going to have to live with here. There is no kind of way to find the accuracy without it. But it's actually not, so it's given a percentage, but it's actually on a scale of 1 to 5, really. So 100% is obviously the best you can get, but you can also get 75, 50, 25, or 0%. So 0% is, when your stone bounces off the ice or something goes completely wrong, or, it has been happening. Well, one of the classic things that happens in curling is you hold on to it a little bit too long. You see these lights flashing on it, and that means that stone is not allowed to be on there. But we won't cover too much on that details. But this percentage is the accuracy across the shots that each player gets. They'll then calculate an average percentage of how accurate that person is.
So I've got questions I don't know if you've got the answers to. This is always, when I've been watching the Olympics and they flash these things up, I've always wanted to ask, right? But I feel like it might be one of those things that is a bit mysterious. So in this case that you've just shown, even I know what Bruce is aiming to do with that, right? So I can see he's done it. Like you say, he didn't need to get bang on the centre. He just needed to be not even in that green zone, right? But if he does any of those things, he's going to get his 100%, right? They're not saying, you missed the centre, so we'll give you 75, right? Mm-hmm. He's done it. But there's something, when you're listening to it, and like I say, I love Rona, the gold medalist who does commentary, sometimes does commentary, and like, what a genius, the things that she can see and the options that are there. So is it like, black ball corner pocket? Do they declare what they're going to do?
I don't believe they declare. It's the scorer decides and kind of how accurate it is. Yeah. So again, it is subjective, but it's also within big bounds. So, you can see when something definitely doesn't work.
Yes.
There are definitely some question marks about this rating. I mean, we're going to live with it for the sake of the analysis today.
Sorry.
Anyway, so this percentage is then taken across the game and across the average of what people do. And this is what we're looking at here. Scotland in their final, what they got. You can see the first, Hammy Macmillan, very Scottish name, got 91%, and then the two middle, and then Bruce brought it home with some 92%, so had an excellent game in that one. So each of the 4 people on the team have a separate accuracy percentage, and they also have it over the competition. But for today, we're going to look at that accuracy over the the shots and over the one game and the team as well, the team percentage as well. Because it's this game of accuracy, does this accuracy determine exactly, is the winning team always more accurate?
Oh, yeah.
This is a question that raises.
I mean, there's going to be a correlation, obviously.
Yeah.
But like you said, there's so much more to curling.
Yeah. So is it?
And
so
I feel like this is
surprises in there.
harsh as well, because that's the point of curling. If you've got good sweepers, again, if you listen to the commentary, they're like, "Oh, that's come out of the hand a bit dodgy.
Yeah,
They'll have to sweep this one." So it's not all on Grant that he's got the lowest one. It's like, well, where were the sweepers, right?
Yeah. So definitely, they can try to save.
It could
save
be because
the shots,
he's not
but,
sweeping.
Yeah. But on the other hand, a good player will always, not need saving by the sweeping. So it's still a team game despite being a solo person, one person doing the thing.
Okay, excellent. So we expect accuracy to be important, but how important?
Yes.
Excellent.
Yeah.
Right.
So this is from the results. We've got the men and women separated.
Yep.
Because they compete separately.
Yep.
On one side, and the blue is the team who won the game, and this is the count of their team accuracy percentage.
Yep.
In red is the team that lost the game, and that's their team accuracy percentage. So this is the distribution of all of them over those 2 years of World Championship games across all of the games, including the knockout stages as well.
Right.
So we can see the distributions are very skewed. So that means that they're going to be generally people are towards the higher end of accuracy scale.
Well, they're at the World Championships.
Yes,
so.
yeah. There's not so many people that go very wrong at the World Championships. But I've got the lines on there for the average for each of those groups
I was
as
going to
well.
say, looking at it, the blue does look towards the right-hand side.
As you would expect, because, you're saying correlation, but it's a binary outcome. It's win or loss. So the easiest way maybe not the easiest way, but a way to look at it, to look at the graphs like this.
Mm-hmm.
And you can see the blue line is above the red line. The winning team generally has higher percentage of accuracy than the losing team in both the men's and the women's. The gaps are around the same. The accuracy percentages are slightly lower in the women's game. The women's games tend to be higher scoring, different strategies. It's quite interesting to watch. I think both of them are interesting sort of in slightly separate ways. But maybe that reflects institutional bias in the people calling the accuracy as well.
Yeah, I was going to say there could be that.
But as you kind of expect at this stage, the winning team is more accurate.
Yes.
Yeah, that's kind of what you would expect to see. So,
I had no idea what the gap would be, though, because it could be, like we say, elite level World Championships. It's fine margins with any sport. Like you say, that's actually, I think, maybe a bit bigger than I expected to see, actually. Yeah. But as you say, there could be. And the fact that it's averaging, again, it is binary, actually. Isn't it? So, anyway, yes, that will iron out some of the differences because you have to go 100 or 75, right? You can't go 89 or something.
Yeah, so the next question I had was kind of like, the most accurate team wins a contest, does the most accurate team win the competition?
Yep.
So this is what a breakdown here is now. Bronze, gold to fourth place.
Yes.
And then teams that didn't medal at the competition at all.
Yeah.
And then looking at their accuracy, you can see if you've got a very low accuracy, you're going to struggle to win. But quite frequently, or reasonably frequently, it's quite a broad distribution. Obviously, it's a small group that win those medals, so it's only a small set of the categories that actually win the medals. But you can see that there's a kind of a spread of them across. So, the gold medalists aren't always at the sharp end.
No.
And then bronze and fourth. It's interesting, there's quite a range between those. Small sample size, definitely small sample size, but it seems that they are the better teams, but they aren't just the right-hand side of the distribution.
No.
Sometimes teams with very high accuracy haven't done anything. That's probably a reflection of the strategy versus accuracy. You can be very accurate, but if you're doing a very, conservative strategy, or you're just like chucking stones down there, like you don't know what you're doing, then maybe not going to do very well. So this is, I was a bit surprised to see this broad distribution, but you can see some teams with very high accuracy haven't won anything, which is interesting. So,
but it might just be that they had a stormer game, stormer game.
Yeah, it could be. So,
and like we saw with the World Championships or European Championships recently, where the GB team were just absolutely
So
smashing everyone, and then they had a nightmare one game, and that's
that was the Scottish team.
Yeah, sorry.
World Championship.
I mean, they're British. They're British.
So
I was
you mentioned earlier about the accuracy not being reflective of strategy. So the accuracy percentage on its own not reflecting, if you're going for a really hard shot.
Yeah.
So if you look at the average accuracy of, this is now first, second, third, fourth. So the people who are doing in the first person generally is setting up easier shots.
Yeah.
The fourth person is having to, either find their way through lots of stones or doing those big clutch shots.
Trying to knock, with a blank in the end, so I need to knock all these stones out. Yeah. Yeah, the first person throwing it down, I mean, I think I'd get kind of that starting paralysis. I'd just be like,
the normal strategy, the first person puts up some guards, puts up some tops.
So I imagine if I'm now looking at how well they did, it's going to be easier to give them 100% or 75 than like we saw Brucey there. There was clear things where he might not be able to get it. Okay.
Yeah. So this is then broken down by
but I did see
position in the team.
So normally you skip the captain, the person who's calling it all. Normally they're the person who throws it down.
Yeah,
last.
they're normally the fourth. Yeah, because they're usually the best. There are some who don't.
Is it GB women? Does our skip?
Yes.
The new skip throw first?
Well, I've seen some variation in some teams.
Anyway.
Yeah. As you can see, though, the first is generally the most accurate, second and third comparable, and the fourth has got that big range because they're making the clutch shots. They're having to do the really difficult shots. So again, this is kind of what we expect. Well, maybe it's not what you expect because the fourth is usually going to be the best player on the team, the best curler, but they're also the least accurate. So if you look at the raw numbers, you might be like, oh, well, they're really bad, but you need to consider that range of numbers from the person.
So this I think exactly proves what my question was, which are they taking the difficulty into account? And the answer is no, they're not.
Yeah. So we have this imperfect, but still, imperfect measure, accuracy measure. It's continuous measure. So we've seen the range go, down from 60 or so for a team up to 100. I don't think anybody's got 100%, but we have that.
Watch the space. This is going to do it.
So we have that subjective measure, it's continuous, and it's what we're looking at is win or loss of a game. So this, to me, says a certain type of analysis, as I think it would to you, is that a way to analyze this sort of data is to use what's called binomial regression. So this is where you fit essentially like a slanted S-shaped curve to a binary outcome, whether it's true or false. In this case, it's going to be loss or win. So it's where the lowest value would be a loss, the top value is going to be a win. And you look across the bottom. So when you're fitting your slanted S, how well that number at the bottom is going to be the accuracy number, how well that's
predicts, like your input.
Yeah, your input is the accuracy number, how well that determines whether you've won or lost.
So we're in let me get this right. So it's a bit like you've used the word regression. So we're back in line of best fit land.
Yes, yeah.
But you've used other things as well. So there's an issue. If we just did a line of best fit like at school, I'm drawing a line on, then like you say, these are, it could predict that I could 1.2 or something like that. Doesn't make sense. I want something that will predict just between 0 and 1, meaning win or loss.
Yes, yeah.
So that's why we've sort of gone from a line into a curve. It's going to take all those inputs and then just try and put us in between those two outputs. Am I right?
Yes. Yep. That's a good way
it's
to
like
describe
so we get this kind of S shape, which we can see what the shape.
Yeah.
The squashedness of that S shape gives information.
A steeper S shape with more flat bits on either side would mean that whatever thing you've got across the bottom, whatever thing you're testing across the bottom, is very good at predicting whatever. The outcome is.
If it's just like some woof,
like if it's like a big step
cut off, then it's like oh wow, at that value, your accuracy needs to be that, and then you definitely win. Whereas if it's more spread out, there's more. What
we see generally when working with this sort of data when it's not suitable, you tend to get your data of being, the dots at each individual value of percentage and then the outcome on it. And you'll get kind of a line floating in the middle that tells you that it is associated, but it's not perfect with it.
Anyway, right. So we've got that. So basically, all
Yeah.
Mrs. Hargreaves needs to know is it's a bit like a line of best fit, but it's a special version that'll take
for picking.
it's just one input, the accuracy, the difference in the accuracies, and it's going to try and predict if you win or not.
Yes. Yeah. So I ran
maths
this.
is going on in the background to help us with
I
that.
ran this binomial regression on the accuracy data, and what we can see in both the men's and women's up on screen now is that actually it's kind of a good indicator, I would say, of win or loss. What we can see is we see dots at the top and bottom. At the top, the dots mean that the team won.
They're all the accuracies for the winning teams, and they're all the accuracy differences.
And the ones on the bottom are the accuracies for the losing teams.
Yep.
And we see that there are some levels of accuracy where you are very, very unlikely to win. That means that line of best fit is straight through 0 through some of those teams. So that's telling you at an accuracy of 50. You've got basically one in a billion chance.
Okay, I'm seeing it now. So if we had those like all the dots on the right and all at the top on the right and all the dots at the bottom on the left, so clear space between them, then like you say, that'd be wow, this is a perfect predictor, and we can even see what the difference in accuracy needs to be. But obviously it's not going to be quite like that. So there's a bit of an overlap, but generally the ones at the top are more towards that right.
It's one of those things where it's like there's no so because there's no flat space on the top right of that curve, it never gets exactly to 1 and goes flat. There's not an accuracy you could say, yes, this means you are going to win. If you hit 100% of your shots,
but there is
win. But there is one you could say when you're going to lose. There's nobody's won a game with 50% accuracy. People have lost games with very high accuracies. So it's kind of a reasonable predictor of it. It's just kind of, we can use this to give us the values we would expect. You can see that in both men's and the women's game, around 85% accuracy, tiny bit lower in the women's game maybe. That means you're more likely to win than lose.
Yeah.
So at that point, if you think of it this way, around 85% accuracy, if you're getting 86, 87%, you lose, that probably means that something about your strategy went wrong on a very rough level. As Jess is about to argue against it.
No, I was just thinking that this does support what we said. Yeah. Like if we'd have had that massive gap, then it would have everything we've just said would have been total rubbish, because you'd have gone, it's all about the accuracy. So it's what we've been saying. Yeah.
But so you can use this as a guide, kind of as a rough guide. As
how much does
if you're getting 90% roughly in both the men's or women's, then you definitely should be winning. If you're getting 90% accuracy, you should be winning. Obviously, you could look at this via later stages of the competition when your opponents are there and stuff like this. We can't fit the differences with this because of the differences is already shifted to the outcome already. But because this is win or loss, the differences is already shifted to the win side. Anyway, so that's team overall. If we look as well at by position, we can see again the same sort of thing that we saw in that distribution. With the and with the first position, you can see what we're saying about a bad predictor line. That's just a general association. It's a rough line. Even if your first is 100% accurate, you're probably not. You're only just more likely than not to win. In both men's and women's. If your first is 100%, it doesn't make much of a difference. But when we get down to the fourth, you can see that gap that we're talking about, that separation. There are no values, or very, very high values of fourth accuracy that have resulted in a win in both men's and women's. And the same thing in reverse, 40, 50%. Even though sometimes in the women's game, 50% might be enough. But, once in the women's game, to be fair. Once in the women's game, 50% could be enough. But generally, 40% accuracy, you're not going to win with your fourth. So this is kind of putting a bit more outcome results on those distributions we're looking at earlier. We can really see now, that what percentages are going to let you down, what percentages would you expect to win. It's interesting that the team average is probably a little bit lower in each case for the win versus the loss. So the team average we saw we needed to win for is around 85% to make it more likely to win than lose on the team average. But on the individual level, it's different for each of the categories, but it kind of goes up. For the skip, if you have 82% maybe, that means you're more likely to win than lose. So it's interesting that goes a bit lower. You need a good team, so team performance rather than just one individual performance. But yeah, that's drawing quite a lot out of a little bit noisy data. But yeah.
No, but I think it's one of those where, isn't it, like we say, on the corridor, we just try and kind of have a little foray into these things. We're not claiming it's going to be the most robust analysis ever in the world. But I think it does fit with that. I think we said this earlier. The data does seem to be telling the same story. That's always a positive sign. If you keep trying to do tinker little things around, and it keeps on giving you the same message, then there's some signal there.
Yes. Yeah.
So we're seeing the same sorts of ideas, aren't we, repeatedly? Yeah. This is interesting.
Yeah. So we can see that the different people's accuracy does matter differently in predicting the outcomes. Yep. So just like you would expect, those last people are the ones that are most important. This is why your last person is usually the best curler. Their accuracy matters more. Even though they have a larger range of accuracies, their accuracy matters more because they're the person who can win or lose you the game.
Yep.
Cool. Right. So, yeah, that's my dipping a toe into curling. As I said, those results books are around 1,000 pages. So I've got there's 84 games, so I've got around 900 pages of analysis to go on those books. So big shout out to Curling Zone and to Curl It. Great resources for this. Loads of people doing curling type analysis on the web as well that are worth looking into. But for today, I think we will see you later.